everyone. Welcome to Azure Digital Twins, powering the next generation of IoT. This is our digital breakout session. We're super excited to have all of you joining us today. My name is Pamela Cortez. I am on the Azure product team, and I will be your host for today. I am here with our main speaker, Christian. He's one of my favorite people on the team, and he is one of our partner PMs focusing on digital twins. He's going to give us all of the updates on Azure Digital Twins and what is digital twins. So let's go ahead and get started. If you're in chat, feel free to ask questions throughout this presentation. We're going to try to answer them all through the presentation and Q&A at the end. And so Christian, we're hearing a lot about digital twins and how it's this next new wave of innovation for IoT. Could you give us a little overview of what digital twins is, and then also what is Azure Digital Twins offerings?
Sure, Pamela, thank you very much, and welcome everybody. So let me actually get to my first slide here. A digital twin is a digital replica of real-world things, places, business processes, or people, designed to understand, control, analyze, and improve real-world business operations. So today we're going to talk about Azure Digital Twins, our development platform for next-generation IoT solutions that model the real world, and a little bit about the background of digital twins. So using the power of IoT, we have connected and monitored individual assets and machines for quite some time now. IoT has made it possible to bridge the traditional gap between design models and real-world products, and that allows us to improve both products and customer experiences. Really, this often involves many types of digital twins. For example, digital twins of an entire factory line that are used to improve the operation of the factory. Or customers really have also started building digital twins of the individual products that they make and ship. And these product twins really help designers and manufacturers to gain a lifetime view of their products, literally from the drawing board, from the design phase to past the recycling board. In the coming phases of digital twins, we will take these capabilities beyond engineering optimization and beyond assets and enable customers to create rich models of entire business environments and eventually networks of businesses in a very holistic manner. And this new generation of digital twins will combine traditional business data with a comprehensive model of many different aspects of reality in a single pane of glass, as a transparent model of a business that can drive operations, analytics, simulations, and optimizations of the general flow of business. Now, today, modeling and creating connected environments is quite challenging, even for a sophisticated business. And that brings us to Azure Digital Twins. Azure Digital Twins is a developer platform for next-generation IoT solutions that model the real world. We will very shortly, within the next few months, release an exciting new preview of Azure Digital Twins that brings our Digital Twins platform to a completely new level. But why digital twins in the first place? Let's talk about an example. So, as a commercial building manager, you traditionally know very, very little about the actual use of a building. And as a result, it is difficult to manage everything from energy consumption, heating and cooling, to space utilization efficiently. So it really seems like a good idea to use IoT data to enable data-driven decisions in the building. But it does turn out that raw IoT data is not all that interesting and informative. To make sense of it, we need context information. We need to know what place a given sensor is measuring, where it is located, what other sensors are around it and correlated to it, and so on. Also, really, as a building manager, you don't necessarily care about sensor readings at all. What you really want to know is which spaces in the building are comfortable, how the spaces are utilized, how satisfied your tenants are with the waiting time in the cafeteria, how efficient from an energy usage point of view your HVAC system operates, and so on. Really, what customers want is they want to reason about the world in terms that match their understanding of that world. And this is really, really important. I want a software solution that describes the world in my terms. So what we need is a scalable design pattern that allows customers to create software models that represent their real worlds. The buildings, floors, rooms, HVAC systems, if you're a building manager, or power stations, transmission lines, and substations for energy grids, or farms, stables, and maybe even cows for a farming solution. And this design pattern is digital twins. Now, one of the core goals for Azure Digital Twins is to allow developers to focus on adding business value and differentiation for their business, instead of having to worry about building and operating complex distributed systems infrastructure at scale. So in summary, the upcoming ADT preview release is built around the ability to model your perspective of the real world, an execution environment that is brought to life with data from IoT sensors using a built-in event-driven data processing system and input and output connectivity. So many of you may already have used our previous preview that we released quite a while ago. The initial preview of Azure Digital Twins was very focused on smart spaces. We got great feedback validating many of the underlying design ideas and concepts, but we also hear very loud and clear that customers wanted to use digital twins for applications in other domains beyond smart spaces. So in response to that feedback, we made quite a number of changes to Azure Digital Twins. So where ADT Preview 1 came with a hard-coded ontology of entities for smart spaces and a topology system focused on the sort of hierarchical relationships tuned specifically for the building domain, the new version delivers a flexible modeling system that lets you design your own custom types, your own entities to represent the things and people that matter in your world. It also lets you create complex graph topologies with much richer connectivity between the entities you model. Customers have also asked us for a more flexible compute model in the original preview than in the original preview, where we let you run custom code as JavaScript functions. In the new version, you can use external compute, for example, Azure Functions, which makes it possible to use existing code libraries and additional programming languages, and you get a much better debugging story on top. In version 1, IoT Hub was integrated and somewhat hidden from view for the developer. That made it hard for customers to use all the capabilities of IoT Hub for device management in the way they wanted. Therefore, in the new version, you can bring your own IoT Hub and you have full access and control over the hub in any way you choose. And finally, we did significant work on enabling solutions at a much larger scale. So let's look at some more details of the new preview of ADT. So real-world environments in ADT are modeled as a topology graph. The entities that make up the graph are called twins, and each type of twin is described as a collection of properties, telemetry, commands, relationships, and components. Really, at the heart of the graph building are relationships. Relationships define how individual twins can be connected to other twins. I always like to think of relationships as the verbs between the nouns, where each entity represents a noun, for example, buildings, HVAC systems, floors, and so on. The verbs are the connective fiber between, right? Building has a floor, HVAC system 2 cools neighborhood A, B, and C, or air compressor is built to customer. Relationships also can have properties which allows for real rich knowledge graphs to be constructed. The way you write twin definitions is using the digital twins definition language, DTDL, which is a simple language based on JSON LD. You see an example for a simple type definition here at the right on the slide. Once you have defined your custom vocabulary in Azure Digital Twins, you can create a graph of twins. Typically, customers do this programmatically, driving the topology, for example, with data that is already available in other databases. For example, a building information management system. We'll actually show a customer example later in this talk for this. In ADT, also, all data changes generate events. For example, incoming telemetry, property changes in the graph, the creation or deletion of twins or relationships, all result in events that custom business logic can react to. Developers can then define event handlers for processing events within the graph and propagate data throughout the graph. Also, very importantly, ADT provides a very powerful query system that lets you extract insight from your modeled environment. Developers can feed the graph with data from external sources, for example, IoT Hub. As I said earlier, unlike in the previous versions of Digital Twins, the new version does not have a built-in IoT Hub. As a result, it's much easier to attach ADT to existing IoT solutions and, of course, to exercise full control over the devices you have and full management operations. Using the ADT REST APIs, it's also possible to drive ADT with data sources other than IoT. For example, you could create a connector for logic apps or other services that can wrap REST APIs. Developers can also define event routes that send selected data out to downstream services. Supported endpoints include things like event hubs, event grids, service buses, and typical use cases include, for example, sending data to cold storage in a data lake to connect to machine learning or other analytics services like Azure Synapse, or to do workflow integration with logic apps. Another important integration candidate is time series insight that you can use to track data over time and apply historian analytics. Really, it's important to think of digital twins as a developer platform. That is, there are no UI components that face end customers at this point. Digital Twins UI is effectively APIs for developers. Think of it as a model component in the sense of a model view controller pattern that developers can use to drive any number of views, such as maps, for example, or data overlays on 3D models or traditional dashboards. Overall, Digital Twins is a platform as a service offering. It's controlled using a rich set of REST APIs. For public preview, we have a C# SDK available that you can use to program against it. And for other languages, you can currently use Autorest to generate a custom SDK. And we will have official SDKs for Java, JavaScript, and Python coming in the near future. There also is a parser library that lets you validate and reflect over DTDL. Typical use cases aside of just validating DTDL on the client side are things such as parsing the DTDL into an object model that you can use, for example, to create model-driven UI from the metadata of the models that you have. Let's switch gear a little bit and talk a little bit about customer use cases. So ADT already is used in multiple business domains across the world. A few example use cases. Edge Technologies is a developer of a new generation of very, very cool, unusual commercial buildings designed to be both healthy for the humans that work in them and sustainable for the environment. Behind that sustainability and comfort of the buildings lies a smart building software platform that is built on Azure Digital Twins. In a completely different domain, Visata is all about manufacturing. As an ISV, Visata provides a platform for manufacturing automation and optimization that is built on Azure Digital Twins and that adds rich AI and data exploration capabilities to the mix. Bosch Building Technologies provides solutions and services for commercial buildings. The software solution is based on Azure Digital Twins and is a great showcase for the power of semantic modeling in generating insight from raw data. Willow leverages Azure Digital Twins to deploy Willow Twin. It's a software as a service offering for real estate and infrastructure customers. The Willow Twin enables owners and operators of real assets to reduce their costs and improve operational efficiency and to better engage with occupants. Let's take a slightly closer look at Visata's platform. What I really like about it is how it demonstrates how a rich domain-specific visual authoring and operations experience can be built on top of the Azure Digital Twins platform. Visata software today is actively used, for example, in steelmaking plants to manage production processes with blast furnaces. Bosch, a multinational engineering and technology leader, pursues ongoing energy efficiency improvements for its customers and, very importantly, for itself. Bosch has committed to a very aggressive date for being carbon neutral by the end of this calendar year. To help with that, Bosch developed an energy monitoring and management solution that is running on Microsoft Azure using digital twins to gain spatial understanding of all their IoT data. With that solution, Bosch customers can apply forecasts and predictive insights to make faster, more informed decisions for improving their building's performance and carbon footprint. At Microsoft, we also strongly believe that comprehensive digital twin solutions are a partner play, where products from multiple vendors together provide a solution that is more than the sum of the parts. To this end, we are also part of the new Digital Twins Consortium as a founding member. There was a press release earlier during Build announcing the foundation of that organization. In this talk, I just want to highlight two of the partners we are working with, Ansys and Bentley Systems. Physics-based simulation has long been an essential part of the product design process, helping engineers to optimize and validate design choices. With the broad deployment of IoT sensors in products and the product environments, it's now possible to apply that same simulation technology after a product has been built, shipped, and deployed in the field, beyond, like the design phase. Simulation technology can be used to optimize performance in the field, to optimize energy usage, predict failures in really accurate and immediate ways without some of the complexities associated with alternative techniques. Ansys is the market leader in technical simulation software, and their Twin Builder product lets engineers quickly deliver real-time simulation models for operational use. With Microsoft's Azure Digital Twins platform, it's then possible to efficiently integrate these simulation cores, these simulation-based models, into a broader IoT solution. In the world of infrastructure development, complex CAD data is the backbone of planning, execution, and operation of infrastructure. Bentley Systems create software tools, CAD systems, and so on for the creation and for the design of these infrastructure solutions. And their iTwin platform captures design geometry and metadata of the project and its environment as the source of truth that drives daily decisions throughout the entire lifecycle of the product. As a developer, you can think of it as a GitHub for CAD. Using Azure Digital Twins, we can bring this backbone to life using raw and processed information from IoT sensors distributed throughout the infrastructure. By bringing a wide range of information sources together into a comprehensive digital twins, including CAD data, real-world scans, photometry, IoT sensor data, weather feeds, and many more, we can really revolutionize the way infrastructure projects are planned, built, and operated. Just a quick look at the overall architecture of a combined iTwin and Azure Digital Twin solution. The iTwin core services are at the lower left in the diagram. iTwin can take in data from a wide variety of CAD systems from different vendors and then apply a rigorous change management and revision control process for the designs. And whenever a particular revision is approved and when data changes, an automatic export task now reads from iTwin and automatically creates and instantiates all the relevant digital twins topology in ADT. And from this point on, ADT can receive and process all the incoming sensor data. Now, ADT will push this data on to time series Insight for a temporal view. It will also push the data to Bentley's open source iViewer platform, which allows customers to see the CAD data from iTwin with overlays from Azure Digital Twins for the IoT data and other sources such as maps for backgrounds, real-world laser scans for complex environmental 3D geometry, and so on and so forth, all into a single 3D view that people can use, to generate insight from their environment. End-to-end, this solution architecture provides an industrial strength workflow to integrate a wide variety of data into a single efficient operational pane of glass. So let's summarize our key takeaways. Digital twins are an important component of next generation business solutions and connected environments. The upcoming preview release of Azure Digital Twins is your development platform for next generation IoT solutions. It's built around the ability to model your perspective of the real world and provides a rich execution environment that is brought to life with data from IoT sensors and other data sources accessible with powerful queries. You get an event-driven approach to data processing and flexible connections to the outside world. Please stay tuned for a future announcement. As I mentioned earlier, the updated preview will be available within the next couple of months. And with that, I'll hand back to Pamela.
All right, thank you, Christian, for giving us that overview and the update on the refresh of Azure Digital Twins. So I'm really excited for folks to get their hands on this the refresh V2 for public preview. So we have a lot of great questions in chat. So I'm going to go ahead and just say these questions to you, Christian.
All right.
I'm going to throw some softballs at you, and maybe I'll throw a couple hard ones for you. So first question is, will any features of digital twins come to Microsoft Teams integration? And then they also made a note, they missed you since your expression blend presentation days.
Wow, that's been a long time.
Thought you would get a kick out of that.
Thank you. Yeah, so the first question, Teams integration. So we are definitely looking at integration with the entire palette of Microsoft products, and the Office products, especially Microsoft Graph, are definitely a super interesting candidate. There are tons of really exciting use cases. We don't have anything concrete to announce right now on it, but it's definitely on our roadmap and something we are very, very interested in doing.
Okay,
and
great.
By the way, if you have concrete scenarios that you would like to share with us, we're always really, really interested in input, like that helps us to design, what we're thinking of in the right way for you so that it really serves your needs.
And how would people be able to get in contact through the tech community, or what would you recommend, Christian, for folks who have feedback?
Yeah, I mean, all the general channels will work fine, but people can also contact our PM alias that maybe you can put somewhere in the chat so that people have a way to have it. That's also a great place to send us messages and let us know about your needs. Okay,
now the next question. Will this replace device twins and IoT Hub, or is this a superset of what is already offered there? This is a really popular question.
Yeah, no, that is a great question. So everything that is an IoT Hub stays exactly the same it is. And we do not assume that every user of IoT Hub has to use digital twins in the future. Obviously, we will be very happy if you do, but you don't have to. So the device twins in IoT Hub is a legacy feature that is very widely used, and we certainly will continue to support that. With IoT Plug and Play in IoT Hub, we add another layer of information about devices that we don't get through device twins. Basically, Plug and Play is a means for developers to create self-describing devices. And these self-describing devices make it very, very easy to create software solutions that automatically can adapt to the devices that are connected to IoT Hub. So think of basically Plug and Play as another layer on top of IoT Hub. And then Azure Digital Twins allows you to create a whole new world of modeled environments on top of these device representations that you have in IoT Hub. Because, of course, plug and play devices are described in the same description language, DTDL, as the twins in Azure Digital Twins. So there's a lot of compatibility in the API surface and in the way how you talk to them, and all the concepts are beautifully aligned. Okay, thank you. And this question I've seen quite a bit actually in Sam's session when he was giving the Microsoft IoT vision and roadmap, and then also in our fire chat last night. Will Azure Digital Twins support running on Edge? For example, our IoT Edge runtime. What is our support looking like for that? So Edge support is definitely on our roadmap. We strongly believe, like in the power of solutions that span the intelligent edge and the intelligent cloud. We will not have edge support right at GA time. It will come a little later, but it's definitely on our roadmap. And again, same ask as before. If you have particular scenarios how you would like to use digital twins on the edge, please let us know. This will be very, very valuable input to us.
Okay, the next one, this is going to be a really popular question as well. So all of those developers working with the V1. So when we announced Azure Digital Twins a while back, and folks are already working with it, what does the migration path look like to get the capabilities in V2? Will that have to be fully transitioned? And then also, are we still going to be supporting V1?
Yeah, great question. So V1 will stay around for a little longer. We will not retire version 1 or the first version of the first public preview, I should say, until after GA of the new version. But we will not keep it running infinitely. So we do recommend all customers who have solutions built or have started POCs on top of the first public preview to migrate to the new public preview once it's available publicly, and to transition onto it as fast as you can, because all the future development will be on the new version.
Okay, and then you mentioned the graph query language earlier. The question is, what is the graph query language?
The graph query language that we use is based on SQL. It's a SQL dialect that is similar to the SQL queries that are used in IoT Hub, with some extensions to express graph queries, to query relationships, and to query through the topology.
Okay, perfect. And then next question is, what indoor mapping capabilities are supported? Is it just imagery, or is there anything more intelligent? Is the solution entirely self-service, or do you offer mapping as a service for users?
Yeah, so again, what I said earlier, digital twins itself does not have any UI components and does not have any built-in mapping capabilities itself. But we do have a very powerful mapping component, Azure Maps. And Azure Maps has just announced at Build their indoor mapping creation tools. And we have already worked with them together very closely to make sure that you can use data from ADT very easily to push it into map visualizations and to drive, like the visuals of maps with data from Azure Digital Twins. So as a mapping component, we strongly recommend to evaluate Azure Maps because it's really a very powerful component to visualize mapping information in conjunction with Azure Digital Twins.
And then one of the most important questions is, when can people get their hands on this? All of the public preview refresh updates. When can folks start playing?
Very, very soon. So it will take a little bit longer. So stay tuned, but within the next couple of months for sure.
And then the next question that you probably already know I was going to ask was, when is it going to GA? Is that something we're going to share?
We're not going to share a concrete date, but we're looking at the second half of this year.
Okay, perfect. And it looks like we got time for a couple more. So let's talk about service integration with our other products and services. One that comes to mind is Azure Time Series Insights. Could you speak a little bit about that and that integration?
Yeah. So we've been working very tightly together with the Time Series Insight team to make sure that it is very easy for customers to not just send telemetry data to Azure Digital Twins, but also topology data, so that you can use all the topology information that is stored in Azure Digital Twins to drive your Time Series Insight hierarchies. We will definitely announce more about that as we go forward. But Time Series integration is definitely very high on our list of priorities.
And there's a question about the slides. What about those great 3D maps we saw earlier in the slides? Is that available? Is that a feature?
Sorry, which 3D maps are you referring to?
I think in the presentation there was imagery of maps, and kind of a
So
3D view.
Yeah, no, sorry. Yes, so the 3D visualizations are basically part of client software that people have written on top of Azure Digital Twins. So as I said earlier, Digital Twins itself does not have its own visualization site. It's a model component, but people have used all kind of 3D platforms from Unity 3D to browser-based 3D to drive properties or 3D geometry with data from Azure Digital Twins. It's actually quite straightforward to do.
Thank you, Christian. Really appreciate it. I thank everyone for joining us, and meet us at our future deep dive January or June 29th. And we're super excited for you to join us for future events. Thanks, everyone.
Thank you very much.